Algebra 1, Lesson 79, Systems of Equations with Subscripted Variables. So hopefully we talked about this in class, but let's talk about what a subscripted variable is. So let's say we have to measure two things like speed or time. Let's say we're measuring how long it takes for us to do our homework, right? And we want to compare two different students. So we'll take the time of one student and then the time of another student. Now these are two unknowns, right? Two different t's, and we want to compare them in one equation. So that can be difficult. Now we could just say that one is A and one is B, but then, what if we're dealing with other things as well as, time and then number of problems. So, time, and then we have the number of problems that they have. So we'll say problems and then problems. So then we've got two different things that are being expressed in the same equation, the same problem, with two different people, and we've got no way of distinguishing the difference between both of them as they interact with each other. So that's where subscripted variables come in. So let's say that our first student, his name is Paul. So we would take the first set of unknowns, and this would be the number of problems for Paul, or P sub P, problems of Paul, and then this would be T sub P, or time of Paul. So we read this as problems of Paul, time of Paul. And then let's say the next student's name is Gertrude. Yes, Gertrude. All right, we would just make that time of Gertrude and then problems of Gertrude, right? Now this is a subscript because it gets written down below. And this is not to be confused with exponents, because we could say, the problems of student number 1 and the time of student number 1, or the time of student number 2 and the problems of number 2, but it's a subscript. So it is a lower case, well, not lower case, but it is a lower letter or number that indicates a difference between two quantities of the same type, but with different value or different ownership. Now, we are eventually going to learn how to solve these in distance problems, and we'll be calling them distance rate time problems, and that's what your book is preparing you for. So all of your examples will have the subscripted variables of R, T, and well, actually, I guess they don't have the distance on there, but they'll be using the subscripted variables of R for rate and T for time. And we'll have something like rate of 1 times time of 1. And then that would be compared to the rate and time of 2. So rate of 2 and then time of 2. So that's how we use subscripted variables. Now the important thing to notice is that time of 1 is not the same thing as time of 2, as we just expressed with our two students. And then the rate of 1 is not the same as the rate of 2. So with that in mind, let's go ahead and start solving some practice problems. Okay, here's our practice problem. Now, one of the things that I do not like about our textbook is the way that they write these problems when they introduce them to you, because a lot of people get confused thinking that this big giant line is all one equation. Not true. You have to look for the commas. All right, I'll go ahead and circle those in red. So there's a comma here, there's a comma here, there's a comma here, and there's a comma here. And this is how your book is going to write it out. And this is where I'm pulling the problem from, right up here. Okay, so it's all written out in one line. Now I put it in different colors to show you the difference between the equations, but you have to focus on those commas in your book so you can see them. Now, given this purple equation, which says rate of A times time of A plus rate of P times time of P equals 460, and that the rate of P is equal to 50, and the time of P is equal to 4, and the time of A is equal to 2, they want you to find the rate of A. So, this is kind of like an overglorified substitution problem, where we just take these values and plug them in for other values in the equation. And this first one's pretty simple. So what we see here is that if rate of P is equal to 50, instead of writing rate of P here, I can go ahead and write 50. And then time of P is equal to 4. Well, let's put that in parentheses so we don't make a mistake. Time of P is equal to 4. So instead of writing time of P, I'm going to go ahead and put 4. That's going to equal 460. Now the last thing they tell me is that the time of A is equal to 2. So put the plus sign. Time of A is equal to 2. I almost wrote time of A again. So that's a 2. Now the only thing they don't tell us is rate of A. So rate of A remains to be our one unknown. And we have to solve for it. But if we see this and we read it properly, we know we just plug these values in and then solve for the rate of A. So let's go ahead and simplify. What color did I not use? Red. Okay, so I'll simplify this equation. 50 times 4 is going to be 200. 2 times RA, or rate of A, is 2 times the rate of A, and that is going to equal 460. Now to solve, I'm going to subtract 200 from each side. So then I get 2 times the rate of A equals 460 minus 200, which is 260. Divide each side by 2, and then I get the rate of A is equal to 130. So that's my final answer for that problem. That one's pretty simple. Let me go ahead and write a more difficult one for you. All right, now this time I've written the problem in all black, and it's kind of hard to look at because we've got a bunch of stuff in a row, but we need to identify the commas. That's the trick to this textbook. So first comma's here, first comma, second, third, fourth, and there we go. I can use that to divide up the equation. So the first equation is right here. This is the one I'm going to be plugging things into. I know that time of F is equal to 16, time of E is equal to 12, and rate of E is equal to rate of F plus 15. So this one is going to have to get substituted in parentheses. And then I'm just going to do the same thing I did above. I'm going to substitute everything into that first equation and then solve for the unknown. Let's substitute in green. So instead of writing rate of F, I guess I have to write rate of F. I don't have any equations that are solved for rate of F. So rate of F will stay the same. Rate of F. Instead of writing time of F, I'm going to put 16. So rate of F times 16 equals rate of E. Now, this is where it gets a little tricky. Rate of E is equal to RF plus 15. So in parentheses, I put rate of F plus 15 in parentheses. Then time of E, I substitute, is 12. So times 12. All right, there we go. I'm done plugging things in. And now I've got an equation with only one unknown, rate of F. I can solve this. We will begin by using distributive property on this right side. So that's going to turn into 12 times rate of F plus 12 times 15. Ooh, what is that? Let's see here, 120 plus 60, 170. So plus 170. Wait, no, is it 170? Hold on, I think it's 180. Let me double check here. Let's see here, 15 times 10, 150. Right, and then 180. What did I do wrong when I did the 12? 12 times 10, 120. 12 times 5, 60. 120 plus 60, 180. Okay, and that is going to equal 16 times the rate of F. From here, I just get both of my unknowns on the same side. So I'm going to subtract 12 rate of F. That's going to cancel. And then 16 rate of F minus 12 rate of F gives me 4 left over. And that's going to equal 180. Divide each side by 4. 4 goes into 180 how many times? Let's see here. 4 goes into 18. 4 times 20 left over, 5. 45 times. So rate of F equals 45. But I'm not done because the problem told me to find the rate of F and the rate of E. So to find the rate of E, I'm going to take this value for rate of F, and I'm going to substitute it in here. So rate of E is going to equal 45 plus 15. 45 plus 15 gives me 60. Rate of E is equal to 60. These are my 2 answers, and I am done. If you have any questions, let me know on Moodle, and I will see you in class.